We're going to introduce now a new rule of exponents. We're going to add one to the list we already have. We're going to add this one here. If we're going to make a division, like we have x to some power and we divide it by x to some other power, here's what we do. We write the common base and then we take the top exponent minus the bottom exponent. There we go. Now, here's why this works. Let's just try a simple example here. What if we have x to the fifth over x to the third? Really, if we expand it out, x to the fifth means we've got 5 x's being multiplied together, and then x cubed, the 3 x's being multiplied. And then, if we have a division here, these x's cancel, right? This will cancel with this will cancel with this will cancel with this, and what we're left with is 2 x's. That is 5 minus 3. Let's just do a bunch of problems now. So the first one we'll start with is y to the 8th divided by y to the 6th. So let's write it as a fraction. Y to the 8th over y to the 6th. Then we're going to subtract exponents, write the common base y, take the top exponent minus the bottom exponent, and we will end up with y squared. Now just imagine what you've got here is if you expanded this one out, you would have a series of 8 y's on the top. On the bottom, you'd have a series of 6 y's. So 8 y's here, 6 y's here. These 6 would cancel with 6 out of these 8, leaving 2. So here in problem 2, negative 48 divided by negative 8 is going to be positive 6. And then y to the 4th divided by y squared, we're going to subtract those exponents. Now you can probably just do this in your head, but I'll write it out. So it's going to be 6y squared. Move on to number 3 here. 15 u to the 4th v cubed divided by negative 3 u v. So negative 15 divided by negative 3, positive 15, right, divided by negative 3 will give us negative 5, and then we'll get u to the, now, top exponent minus the bottom exponent. How about 4 minus 1, and v to the top exponent minus bottom exponent, 3 minus 1. So we're going to have negative 5 u to the third v to the second. Now it's pretty common in mathematics and physical sciences to write a u like this. If you're writing it by hand, you write it like this, and a v like this. Because if you just write it like this, a u or a v, I don't know which one that is. So I make this distinction like this. And in number 4, positive 10 divided by negative 5, negative 2. S to the, let's just do this one now. 5 minus 1 is 4. T to the 3 minus 1 is 2. Now I'm doing top exponent minus bottom exponent. You can also just think this way, right? I've got 5 of these s's on top, 1 on the bottom. That 1 on the bottom will cancel with one of those 5, leaving 4. And in number 5, let's make this division. 25 divided by negative 5 is negative 5. And then x to the, now I'm going to write this one out. This is going to be top exponent minus bottom. So we'll get an 8 minus 6. Y to the top exponent minus the bottom exponent, 6 minus 6. And then z to the top exponent minus the bottom exponent, 7 minus 4. This is going to give us negative 5x to the 2. Y to the 6 minus 6 is 0. And z to the third. Now, we're going to make a definition here. This is going to come up every now and then where you have a quantity to the 0 power. And we're going to define this to be 1. Right? So a non-zero, this is, of course, if y is not equal to 0. 0 to 0 is undefined. So if you have some non-zero number to the 0 power, that's going to be a 1. So this y to the 0, that's a 1. So we're going to have this. We're going to have negative 5 x squared times 1 times z cubed. But the 1, that's not going to change anything. So we're just going to write this as negative 5 x squared z cubed. And this y to the 0 being 1, well, we can kind of understand it like this. Look back up here. What is some number divided by itself? It's 1, right? Y to the 6 divided by y to the 6 is just the 1. So this is a reasonable definition. In number 6, let's rewrite it as a fraction. Let's write it as 28x to the 6th minus 49x cubed all over 7x. Let's just point this out here, make you know this. But x to the 6th, x cubed, these are different things, so we can't combine these, right? These are 28 of these things minus 49 of these other things, so they don't combine. But let's divide it by 7x. Now, as long as the denominator has one single term in it, not 2 or 3, but just one term, we can divide this up into separate fractions. We can write this as 28x to the 6th over 7x, and then minus 49x to the 3rd over 7x. And then making these divisions, 28 divided by 7 is 4, x to the top exponent minus bottom, 6 minus 1 is a 5, minus, and then here, 49 divided by 7 is a 7, and 3 minus 1 is 2. Number 7, let's write it as a fraction again. How about x to the 5 over x cubed plus 5x to the 4 over x cubed minus 5 over x cubed. And making the first division, x to the 5 minus 3, right, top exponent is minus bottom, will give us x squared plus, now here we'll get 5, and then top exponent minus the bottom, 4 minus 3 is 1, so it's just an x, minus, now in this case, there's no x's up here, so we can't do anything here, right? These x's on the bottom are not going to cancel out with anything. So we just have to leave this term as it is, minus 5 over x cubed. That's just the best we can do with it. Now, in problem number 8, we've got these 3 terms up here, pretty big ones, divided by, but only one term in the denominator. So we're going to write this as 1, 2, 3 individual fractions with this as our denominator. So let's do that. All right, so I went ahead and I broke these fractions up. So the first term over the denominator minus, second term over the denominator plus the third term over the denominator. So let's make these divisions now. So 15 divided by 5 is a 3. And now the x, or the w, top exponent minus bottom exponent, 8 minus 2 is a 6. So we'll get w to the 6th, y to the 9 minus 1, right? We don't write it, but there's a 1 there. 9 minus 1 is an 8. And then minus 25 divided by 5 is 5. W to the 6 minus 2, 4. And then, can't see it too well here, y to the 7th divided by a single y is y to the 6th, right? 7 minus 1 is 6. And then plus 25 divided by 5 is 5. W squared divided by w squared, that's just going to be a w to the 0. We'll fix that up in the next round, the next pass. Y to the 3 minus 1 is a 2. Now right here you've got that w to the 0. You know that's going to be a 1, so we could have just written that a 1 there or just left it out. So let's write our conclusion here. We're going to write this as, let's see if we can write it, 3 w to the 6th, y to the 8th, minus 5 w to the 4th, y to the 6th, plus 5 times 1 times y squared. I just don't need that 1 in there. And this is coming from this one here. Remember our definition that x to the 0 is equal to 1 as long as x is not equal to 0.